Welcome to the module on concrete. In this module, we will be discussing about the design mix of concrete. What is the need of the design mix? What is the definition of a design mix? And how to do the design mix? What are the controls required in order to do the design mix of concrete as per the Indian standards is being discussed in this module. What is a design mix? Design mix of concrete is the process of choosing suitable ingredients of concrete and determining their relative properties with the objective of producing concrete of certain minimum strength and durability and ease of placement consolidation as economically as possible. That means generally in the earlier days we used to have the nominal mix where you mix the ingredients at a certain fixed proportions and do the concreting. There is nothing much you can do as far as the optimization of the concrete is concerned in case you are using a nominal mix, whereas if you are going for a design mix, you can do the design based on the required strength, based on the workability, as per their requirement, as per the individual's requirement, the concrete can be designed. This is the biggest advantage of a design mix as compared to the nominal mix of concrete. What is the need for the design mix of concrete? We need to design the mix in such a way that this will result in minimum use of costlier materials. Generally, we call it minimum use of cement. Maximum lifespan, that is the durability of the concrete, should be as high as possible and should be able to achieve the desired strength of concrete. Like for example, if it is M40, it should at least meet the acceptance criteria given in IS 516 for M40 grade of concrete. Steps involved in design mix of concrete. The different steps that are being involved in design mix of concrete are given below. One is design stipulation, then the exposure conditions, the degree of quality control one can exercise in order to produce the concrete, properties of the ingredients locally available to mix the concrete, the target strength and selection of water cement ratio, calculation of the water content, determination of cement content, determination of coarse and fine aggregates, then the calculation of mixed proportions under SSD conditions. To start with the design stipulations, one can expect the following informations to be available with him before the start of the design mix. That is, he should be knowing what is the grade of the concrete he is designing for, the type of the cement available locally, the type of aggregate available, and the target strength which he is aiming for, which is normally calculated based on the standard formula given in the Indian standards IS 456 or SP23 or IS 10262. Maximum size of aggregate for which the concrete is being designed. It can be 10 mm, it can be 20 mm, it can be 40 mm, or else it can be 150 mm also, depending upon the use and the degree of requirement. Then the workability requirement, one should know before designing the concrete, the minimum cement content, the maximum water cement ratios, the degree of quality control one can exercise in order to produce the concrete or use the concrete, the exposure conditions where this concrete is required, maximum cement content, and chemical admixture types. So this is the information which normally one will get in order to start the design mix of concrete. For example, if you are going to design M40 grade, the type of cement available, suppose you see, is OPC 43 grade conforming to IS 8112. The maximum nominal size of the aggregate is 20 mm. Minimum cement content is 320 kgs per cubic meter. Maximum water cement ratio is 0.45. Workability requirement is 100 mm. Exposure conditions are severe for reinforced concrete. Method of concrete placing, say this is to be pumped. The degree of supervision is a good. Type of aggregates are crushed angular aggregates. Maximum cement content is 450 kgs per cubic meters, and the type of chemical admixtures is, say, superplasticizers. Exposure conditions are defined as mild, moderate, severe, very severe, and extreme. Mild exposure condition is the one where concrete surface are protected against weather or aggressive conditions, except those stipulated in coastal areas. Severe conditions are defined as a concrete surface exposed to severe rain, alternate wetting and drying, or occasional freezing while wet, or severe condensations. Concrete completely immersed in seawater, concrete exposed to coastal environments will be covered under severe exposure conditions. Moderate exposure conditions are such surfaces or such concrete surfaces sheltered from the severe rain or freezing while wet, concrete exposed to condensation and rain, or concrete continuously underwater, concrete in contact or buried under non-aggressive soils or groundwater, concrete surface sheltered from saturated salt air in coastal areas will be covered under moderate exposure conditions. Very severe exposure conditions are defined as concrete surface exposed to seawater spray, corrosive fumes, or severe freezing conditions while wet, concrete in contact with or buried under aggressive subsoils or groundwaters are covered under the very severe exposure conditions. Extreme conditions are the conditions where the concrete surface of members are in tidal zone, members in direct contact with a liquid or solid aggressive chemicals will be treated as exposed to extreme exposure conditions. Coming to degree of quality control, degree of quality control again is divided in three categories, that is very good, good, and fair. Very good category is considered when the fresh cement from single source and regular test, weigh batching of all materials, aggregates are supplied in single sizes, control of aggregates gradings and moisture content, control of water added, frequent supervisions, regular workability and strength test, and there is a field laboratory facilities available at the site, then such conditions are said to have exist, and a very good quality control, degree of quality control is being maintained in the project site. A good degree of quality control is considered when a carefully stored cement and periodic tests are being conducted, weigh batching of all materials is being done, controlled water, graded aggregates supplied, occasional grading and moisture test is being conducted, periodic checks of workability and strength are being done, intermittent supervision and experienced workers availability will cover the good degree of quality control. The degree of quality control is said to be fair when a proper storage of cement, volume batching instead of weigh batching of all aggregates allowed for bulking of sand, weigh batching for cement, water content controlled by inspection of mixes, and occasional supervision and test are in place, that then the degree of quality control is said to be exercised as fair degree of quality control in place. Properties of ingredients used to produce concrete are specific gravity and water absorption to be tested, flakiness index to be tested, silt content, aggregate impact value, aggregate crushing value, gradation, and the abrasion value of the aggregates needs to be tested for the ingredients or the aggregates which are being used to produce concrete. Calculation of target strength. The target strength is being calculated using the formula Ft is equal to FCK plus Ks, where Ft is the target mean strength, FCK is the characteristic compressive strength, S is the standard deviation as detailed in table 1 of IS 10262, K is the statistical value generally considered as 1.65. K is a constant depending on the definitions of characteristic strength and is derived from the mathematics of normal distributions. So if the M30 grade of concrete is required to be designed, then the target strength for M30 grade of concrete is FCK value will be 30 plus the K value will be 1.65 and as the standard deviation will be chosen based on table 1 of IS 10262. Table 1 of IS 10262 says that for M10 and M15 the S value is 3.5, for M20 and M25 S value is 4, and for grade of concrete between M30 and M55 the standard deviation value is 5. So 30 plus 1.65 times 5 will give you the target strength for M30 grade of concrete as per IS 456. Coming to selection of water cement ratio, based on the target strength, the water cement ratio is obtained from the established values or will start with the values given in table 5 of IS 10262. Maximum water cement ratio for the said exposure conditions is checked from the table 5 of IS 10262. The value of water cement ratio obtained is acceptable if it is less than the maximum. So this is the table figure 2 showing you in x-axis you have the water cement ratio, in y-axis you have the 28 days compressive strength. So for each grade the compressive strength, like for M30 you know that this is the compressive strength at 28 days, and if your type of cement is A, B, C, D or if F, so if the type of cement is say B, then the corresponding water cement ratio considered should be somewhere between 0.45, 0.4 and 0.45. That means it is somewhere between 0.41. So since 0.41 is less than the maximum water cement ratio, so this can be accepted as the selected water cement ratio for that particular grade of concrete to be designed. Table 5 talks about the minimum cement content, maximum water cement ratio and the minimum grade of concrete for different exposures with normal weight aggregates of 20 mm nominal maximum size of aggregate. You have been given the exposure conditions and you have been given the minimum water cement content and maximum water free water cement ratio for both plain as well as the reinforced concrete, and the minimum grade of concrete to be defined as M15. Selection of water content. The water content can be determined from table 2 of IS 10262 based on the nominal maximum size of aggregate. The water content given in the table is for angular coarse aggregate and for 25 to 50 mm slump range. For desired workability, the required water may be established by trial or an increase by about 3% for every additional 25 mm slump or by using a chemical admixture conforming to IS 9103. Water reducing admixtures reduces the water by 5 to 10%. Superplasticizers admixtures reduces water by 20%. So table 2 of IS 10262 talks about maximum water cement water content per cubic meter of concrete for a nominal maximum size of aggregate, say 10, 20 or 40. So if you have been given to design the concrete with a nominal maximum size of aggregate as 20, then your maximum water content in terms of kgs will be 186. These quantities of mixing water are for use in computing cementitious materials contents for trial batches only. So you know the water cement ratio, you know the water content, so you can easily selection of water content. So from table 2 you got 186 for a slump of 25 to 50 mm slump range for 20 mm aggregate. Estimated water content for 100 mm slump will be 186 plus 6 by 100 into 186, that is around 197 liters. As superplasticizer is used, the water content can be reduced up to 20% and above. So based on the trials with superplasticizers, water content reduction of 29% has been achieved and established. So the effective water cement ratio will be 197 into 0.71, that is 140 liters. Determination of cement content. For a selected water cement ratio, the known value of water content, the cement content can be determined as cement content is equal to water content divided by the water cement ratio. Cement quantity obtained above should meet the requirements of minimum cement content as per the table 5 of IS 10262 for a given exposure conditions, and the greater of the two values will be adopted for the design mix. If you see the calculation of cement content, you have know that the water cement ratio is 0.4. The cement content is equal to 140 divided by 0.4, that is 350 kgs per cubic meters. From table 5 of IS 456, minimum cement content for severe exposure conditions is 320 kgs per cubic meters. Since in this case 350 kgs per cubic meter is greater than 320 kgs per cubic meter, so 350 kgs per cubic meter will be adopted for the design mix of concrete and is find OK. If you see the individual gradation of fine aggregates, you have sieve sites and the equivalent BS sieve size. And for fine aggregate, you have zone 1, zone 2, zone 3, and zone 4 sand required to be passed. Gradation of fine aggregate has to be done. It should be defined as the zone based on the percentage. Gradation of coarse aggregates also requires to be checked. Individual grading for 20 mm and 10 mm. So now percentage passing for single size aggregates is given, and percentage passing for graded aggregate of nominal size is being given in tables. So now you have the coarse aggregate gradation, individual grading to be checked. Now all-in aggregate grading is given in IS 10262, that is for 40 mm nominal size aggregate, a set of sieves and the set of percentage passing is required. For 20 mm nominal size of aggregate, maximum size of aggregate is 40, and then 20 mm sieve you have 95 to 100% passing, and at 4.75% mm sieve you have 30 to 50% passing. At 600 micron sieve you have 10 to 35% passing, and at 150 micron sieve you have 0 to 6% passing. So what is required is in all-in aggregate grading, you know the individual grading of 10, 20 and fine aggregates, and you know the all-in aggregate gradation requirement. So you need to give a mathematical model to check what is the proportion of 20, 10 and fine aggregates should be added so that it will meet the all-in aggregate grading requirement. And then theoretically you match the all-in aggregate grading requirement. Once the theoretical grading is being done, the required quantity of aggregates needs to be taken and then sieved to check that whether the physically or actually the percentage passing is being achieved or not. Estimation of coarse and fine aggregates. Volume of coarse aggregate per unit volume of total aggregate is determined based on the different zones of fine aggregates as per the table 3 given in IS 10262. The values given in the table are for water cement ratio of 0.5 and other water cement ratios. These values can be suitably adjusted, say plus minus 0.01 for every change of water cement ratio by 0.05. For pumpable mixes, these percentages can be reduced by 10%. Table 3 of IS 10262 gives volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregates for a given nominal maximum size of aggregates at 10, 20, 30. So for example, if you have a MSA 20 and sand in zone 2, then volume of coarse aggregate per unit volume of total aggregate should be 0.62. From table 3, for coarse aggregate corresponding to 20 mm and fine aggregate to zone 1, you for water cement ratio of 0.5, you have volume 0.6. In presence of in the present case, water cement ratio is 0.4. Therefore, volume of coarse aggregate is required to be increased or decreased to the fine aggregate content. As the water cement ratio is lower by 0.1, the proportion of volume of coarse aggregate is increased by 0.02 at the rate of plus minus 0.01 for every 0.05 change in water cement ratio. Therefore, corrected proportion of volume of coarse aggregate for the water cement ratio of 0.4 will be 0.62. For pumpable concrete, these values should be reduced by 10%. So 0.62 multiplied by 0.9 will be equal to 0.56. Therefore, volume of fine aggregate will be 1 minus 0.56, that is equal to 0.44. Volume calculation. Consider that the volume of the concrete is 1 cubic meters and volume of water is X. So volume of chemical admixture is Y cubic meters. So volume of cement is calculated as Z cubic meter and the volume of all in aggregate is E cubic meters. So volume of all in aggregates E is equal to 1 minus X plus Y plus Z. So in the example, volume of cement is mass of cement by specific gravity of cement into 1 upon 1000. So you will get volume of cement is equal to 0.111 cubic meters. Volume of water is again calculated as mass of water by specific gravity of water into 1 upon 1000, that is 0.14 cubic meters. Volume of chemical admixture, that is superplasture, which is 2% by mass of cementitious materials is considered. So mass of chemical admixture divided by specific gravity of chemical admixtures into 1 upon 1000, that is 0.006 cubic meters. So mass calculations will help you. Mass of coarse aggregate calculated as A into volume of coarse aggregate into specific gravity of coarse aggregate into 1000. Or mass of fine aggregate is calculated as A into volume of fine aggregate into specific gravity of fine aggregate into 1000 in kgs. So mass of coarse aggregate is equal to 1140 kgs and mass of fine aggregate is equal to 896 kgs. Now the mixed proportions, if you see, the quantities obtained for water, cement, fine aggregate, Ca1 and Ca2 are noted. The proportions obtained by converting the values for one bag of cement are noted. So mixed proportion is cement is 350 kgs, water 140, fine aggregate 896, coarse aggregate 1140. Chemical admixtures is 7 kgs per cubic meters and the water cement ratio is 0.4 for this design mix. Under the coarse aggregate, again you have 20 and 10 mm. So based on the proportions of 20 and 10 mm, like if it is 50-50, then 50% of 1140 will be 20 mm aggregate and 50% of 1140 will be 10 mm aggregate. So depending upon the proportions of 20 and 10 mm aggregate in the mix, the coarse aggregate total quantity can be divided into sub quantities of 20 mm and 10 mm. Adjustment for absorptions and free moistures. Extra water to be added for absorption in coarse aggregates and deducted for free moistures in fine aggregate to obtain the actual quantity of water required. Adjustments in fine aggregate quantities for free moistures to be added. Adjustment in coarse aggregate quantities for absorption to be deducted from the fraction Ca1 and Ca2, that is 10 mm and 20 mm. The corrected values of water, fine aggregate, coarse aggregate, Ca1 and Ca2 obtained for mixing of concrete in a controlled conditions. The concrete mix is checked for workability test to suit the requirements. The mix is checked for cohesiveness. The cubes of size 150 by 150 by 150 were cast, cured and tested for 3 days, 7 days and 28 days compressive strength. The values obtained in the compressive strength should meet the requirements of the target strength. For meeting the workability requirements, the admixtures are used. The admixture quantity is to be added in the mix at the time of mixing of water. Quantity of admixtures arrived by heat and trial and refer manufacturer's data as a guideline to use the doses. After adding the admixtures, the slump test is done to confirm the requirements of the workabilities. Once the workability conditions are met, the compressive strength test is done for the same mix to check the strength requirements. Observations and remedies. If the observations are understood, that means increasing the sand content in multiples of 5% will hopefully solve the problem. If the mix is non-cohesive, vary proportions of aggregates amongst themselves. If you have a lack of workabilities, increasing water cement content, that is a change of water cement ratio or change of admixture doses will help to meet the workability requirement. TMS not achieved, that is target mean strength is not achieved, that means reducing the water cement ratio in multiples of 5%, maintaining the total water content or increasing the cement content is the hopeful proposal to achieve the TMS for the required mixtures. Summary of this module, that is design mix of concretes guideline, is we talked about the importance of design mix of concrete in terms of against the nominal mix of concrete, how the economical designs can be achieved by following the norms of design mix given in IS 10262. What are the procedures to conduct the design mix of concrete as per IS 10262? How the calculation is done for the design mix of concrete using the guidelines given in IS 10262 or SP23. The different charts like charts for calculation of cement, water, and the different tables given for standard water content, or all those things are being covered. The importance of admixtures in fulfilling the workability requirements, like how important it is to make your mix cohesive and workable so that it can be designed based on the congestion of the reinforcement or the flow of the concrete, and how to do the proportioning of coarse and fine aggregates, like you can have the individual grading and then mix theoretically the different aggregates like 10, 20 and sand, and check whether they are in a meeting the requirements given in the standards, and then once the proportions are fixed, theoretically the practical approach is being done to verify that the proportions considered are correct. Thank you.